Mark, what did you notice today? What should you notice? How many people are here today versus normal?
Less.
It happens whenever this stuff do. I don't get it. You know?
Quick update, decidedly no break.
Decidedly no break.
Yes.
Get out early.
Yep.
So what I'm taking that is you don't want to listen to me at all. So get through it as quick as possible. So-
I sent one out and I sent an email. Yeah. I was pretty loud about it and I wasted time during class.
oh,
Yeah.
yeah, but that's, again, not any different than normal, so.
In general, if you need a break, just get up and go do it.
And this is in alignment with the last three that I've done that decided to do that.
Oh, I closed it already.
Cooper, say it again.
Yeah, you can just get up and.
No, not that.
Oh, you were right on.
Ah, thank you. Thank you. That's what really happens. All right, so who would like to walk through their first one? Or do I have to, like, just make somebody come up here and do it? Okay, I gave you a chance. Now you may just have to do it. And Cooper, I'm not gonna make you do it because you've do too much stuff already. Or I will just randomly pick and then we'll walk through somebody's. How about that? That way you don't have to stand up and do it. All right, so let's take a look at this one. So, user is responsible for all shared hardware devices in the building. Approximately 525 devices installed in 300 offices. Each device can be shared by any number of users. So, first off, how many things are there? Three, right? So you guys are all scared to come up here and you all answered correctly, right? So I get that. All right, so that's all right. So, if we look at this one, we have the fact that we have device, user, and office. Is that what you all came up with?
We call office something different.
Okay, but location, right? Yeah.
I put one entity called technician,
Technician, how,
because it's for, it says, how many did you install? It asks for the date when it was installed.
right, but you have to go by the description you have been given. Right? Now, if someone said it was installed by a technician, then you now have another thing. Right? Okay, so you, and I didn't even pay him for this, but it's great. Right? So, what did he do? He inserted his own stuff into the assignment to make it harder. Right? That's what he did? Okay. We do it in real life too. We add stuff. We start assuming things. We make up things, right? This implies this. And what should it really represent? Everything that is possible, right? That's what you're creating. And whatever it is that you have needs to be verifiable by somebody. Right? So in your scenario, you say, oh, I saw this piece of data, so that means something happened, so therefore there is this thing. Right? So technically, right, you could imply that not only do we have a technician, but we have a whole set of employees. So user could turn into employees, where it's made up of users and technicians. Right? So I mean, we can break it down to all kind of different levels, and that's exactly what we're going to talk about when we get to these slides for today. Right? But what I'm asking you to do is to only go by what you have been given. Right? Because that's the information that has been provided to you. Yeah.
So this is an honest question. The problem.
Oh, so you give me dishonest questions? Is that what you're telling me?
Yeah, I'll qualify those two next time.
Okay.
Yeah.
No wonder you have to sit next to him and watch him, Kendra.
The problem statement just doesn't distinguish between office and building. Are we to imply that those two things are the same, or that they should be part of the same entity? Sort of how do we deal with ambiguity when we're reading a problem statement? What kinds of decisions do we get to make as modelers?
None.
Perfect.
You get to make no assumptions. Because clearly you were not listening when I talked to him. Right? What do you need to do? If there's anything ambiguous,
Ask questions.
ask questions
Yeah.
to someone. There is someone in the organization that should be able to give you the answer to whatever question you have. And if they can't, then your organization has a different problem. Yeah.
So for the instance of this class, how do you want us to embrace ambiguity here, since we don't have anyone we can actually go and ask these questions to? I mean,
You
aside from you, but I don't think it's.
Oh, I mean, so for those of you online in the back, we have a person who is asking in the class dishonest questions, and somebody who has no one to ask questions to because I clearly can't answer any of the questions. Listen, I can read between the lines just like you guys can, okay? So, all right,
I guess
so.
I'm saying like a test scenario.
Okay, so here's the exact way that I handle exams. All right, it's clearly, if you're not asking me, it's not ambiguous to you. Otherwise, you'd come in, ask me, unless of course you feel that you can't ask anybody a question. Right? But the point being is that if I read an answer any answer, right? Not just on something like this, but any answer, and you answer it completely differently than I intended the question. But I read your answer and I go, wow, I never thought of it that way, and I can see how you got to that being the question. Then I'm going to grade it on what you have given me. Right? Because otherwise you'd ask me. Right? So in a case of, right, the office versus a building versus a location versus a cubicle or whatever, right? As long as what you have put is reasonable, I'm okay with it. Right? So, but in real life, you are literally going to have those kinds of ambiguity, but they're the same. So where would you go if you were lucky enough in a company that had one? Where would you go? No? Data dictionary, right? Because the data dictionary is going to list all of the aliases that you have for that word or that phrase. So I would see that buildings represent an office, represent a cubicle, represent a location, right? Whatever it happens to be. And you'd go, I get it. Right? But since most companies don't have those, you have to ask someone. So hunt far and wide to find someone that can answer a question. And once you find that person, then you say, are these the same? Are they different? If they are different, how are they different? If they're the same, why are they called different things? Right? Because every company, right, so stepping back, right, as we've kind of talked, every company, every organization, every place that you go, including probably your family, is going to have their own language where words have certain meanings to you that if you say them to somebody outside of the family, the organization, they interpret it differently. You have any of those, Mark?
A couple.
A couple?
Yeah.
Yeah?
Can't share any.
Right. Too much info, thanks, Mark. Right? But the point is that one of your jobs when you go work someplace, one of your first jobs is to understand or learn the language of where you work. Because if you don't get that, then you're going to misinterpret things. Right? So, and they're using in a lot of cases, they're using the exact same words. Right? So, as an example, I know this, thanks for getting me sidetracked on this, it's okay. Right? But right, when I was a database administrator, one of my jobs was to consolidate data from different databases into one. Because we were going global, because that was a cool thing to do. Right? So we had so this was at GM, so we had a data field called market area. And it was called market area everywhere. So it wasn't different terminology that we forced into that, but if you look on the different databases around the world, they had the words marketing area. And when I drilled into it, I found that there was 36 different definitions worldwide for the exact same two words of marketing area. So now what do you want to do if you're going to consolidate? Like I got it down to 6, right? But everybody had to agree on what their version of it meant, right? And then I had, instead of marketing area, I had descriptions that described these 6 different fields because they all meant different things. Okay? So it's not even ambiguous because they're using different terms, like in this case, this one was the opposite. The same words had multiple meanings depending on where you were at. And what's the problem with that within an organization?
Now you don't know what it is.
well, people move within an organization and you move to another part of the organization, you hear the term that you already know, and it's not the same definition. Right? So we as companies, especially global companies, or when you have companies that merge together, right? There's lots of mergers that happen, things like that. Right? This turns into a big problem, and then that translates, and this is why we're talking about it, because our databases are mirrors of the language you have at a company. So managing how that works, you have to understand it so that you can obviously do this. All right, so be ambiguous as long as it makes sense. How's that? Now, you notice, Cooper, that she just said, that's perfect, not like you say that I'm perfect, okay? So it's a little bit different, so I did note that slight difference. Okay. All right, so we have device, user, and of. So again, people put just the word device, right? Right? Again, there should be somewhere, if you have this done correctly, a data dictionary that would define exactly what this means, right? Okay, so we have a user and we have employee ID and we have their name and we have a phone number and we have for the office, we have a floor and a room number. Okay, so let's just ask a question here. So we have 2 underlines. What does that mean? Since you guys are all experts at this. So what kind of key is it? Composite. It's also primary, right? Okay, so composite, because it's multiple, right? And okay, so if we look at the hardware device, we have manufacturer, type, install date, stuff like that. Okay. And okay, so here's the complete. Okay, so okay, is the device related to the user? You guys all have that? Right? So again, depending on the order that you place them, the wording can be different, but there should be a relationship, right? So device is used by a user, and device is assigned to an office. Okay. Okay. And then what do? We pick another entity, and right. So we go to user, and we go back to device. Right. So a user uses a device, so working in the opposite direction, right? Does that make sense? Yeah, okay. Okay, and user works at an office, located in an office, right? Assigned to an office, or I mean, you can use all kind of words associated with that. Okay, and then if we go to office, right? Office has a user working in it. Okay, and a office is a assigned device. Okay, and then from a cardinality perspective, a single device is used by 0, 1, or many users. That's what you guys had? Okay. And a user uses 0, 1, or more devices. Does a user have to use a device? And say they have to, right? Okay, all right. A user works at one and only one office. It wasn't specifically stated, but that would be an instance of a valid thing that you could state, right? Okay. Okay, and a office has 0, 1, or more users assigned to it. Okay, device is located or installed at one and only one office, and an office has 0, 1, or more devices. Right, so that looks a reasonable one. So again, your wording can be a little bit different, your cardinality could be a little bit different, but the basic gist is they are all related to each other. Okay, so we numbered those. Okay, so Office where each device is installed, and they say 1, 5, and 6. Right? Everybody have that? Okay, that makes sense. Okay, the date installed. Okay, so that's just off of 1 because they had the install date on the. There's a piece of data here. Okay. Is that the only place you could put it? Where else could you put it? In the office? Really? Why could you put it on the office? Well, your office can have 0 or more devices, so the install date doesn't seem that you would want to put it on the office because which device is associated with that? If there's multiple, I have 4 of them, that could get messy. Right?
You do it off the relationship in between.
Yeah, so the other one is off the relationship, right? So that one is going to be 2 favorite words in IT? It depends, right? So as I said, there are some organizations that will not allow you to have attributes off of a relationship unless it's a many-to-many. And the reason for that is because typically, if you need to build a many-to-many, it's going to be its own database. So you're physically going to create it. Right? If I have, like we have in this case, a one-to-many, and I have it off of the relationship, you have to determine where it's going to go. And right, again, there is no standard way that this is done. There's no standard format for the look that it has. But the idea is it has to be somewhere because it's in the description and you've been asked for it. And the likely place, if you're going to actually have that field and have it filled in, you are going to have it associated with the device because that's a thing that is actually physically being installed. So since I'm going to put it there anyway, I should probably put it with the device. But again, right, if you feel that it's off of the relationship, that would be, for me, if I was to look at it, that would be okay. So, okay. So that was a 1. Users authorized to use the device. Okay, so 1, 2, and 3. Okay, you guys all had that. Okay, 10 devices with the most users or the least users. Okay, that's still going to be 1, 2, and 3. Okay. All right, total devices installed. Okay, that's going to be number 1. So that implies that we may not have an install date. So it's just kind of sitting around because it's not installed somewhere. So we can have a count of those. Okay, average devices per office, office with the most and the fewest. So I'll do that route. That's okay. Okay. Users authorized to use devices in more than one office. 1, 2, 3, 5, 6. Wow. Is that what you guys had? Yes? No? Maybe? Okay. Anybody have something different? Okay. So, okay, so where are we at? Still don't have any 4 anywhere. Okay. The list of offices without a device. So 1, 5, and 6. Right. So we have the complete as shown, and the build is going to be everything but the relationship between user and office. Okay, that's what everybody had. So you guys are all perfect. Okay. That sounds good. All right. And then what was the next one? Oh, the manager of the air freight service. So 700 routes traveled by some of the firm's 850 planes. Okay, some of the customer packages are assigned to a particular route. Each route is assigned to a particular plane each day. Who's are we going to look at for this one? All right, now let's go out and pick Anna. All right, so in this one, it looks like we have routes, planes, and packages. Is that what you guys have? Customers. You need customer? Is customer a thing that you as a company are dealing with? Yes. Right. It has been described to you in the description. You are picking out all the things, right? That's that noun extraction. You're looking for all of the things. Now, you may find that you don't need to store any data about a customer, but does a customer exist in what you are dealing with? And another way to look at it is there some potential that you would, in the future, not necessarily what you have here, if you had a need, the user comes up to you and says, I want to keep track of all the customers I have that have ever shipped anything with us. If this is not on the complete ERD, you don't know that it's even possible to get that data. If it's on the diagram and it's not part of the build, you go, I don't have it built yet, but it is possible to get the data about a customer. Because a customer is part of what we deal with as a company. Okay, so is that cleared up for you? Okay. All right. Okay, so we have a route with a route number, destination, departure, distance. We got a plane number, aircraft model, and capacity. Oh, we love capacity, right? And a package is we have the customer, right? Address to and destination, right?
I have a question.
Yeah.
Route, when you look at it, isn't that an abstract thing, whereas an airport per se is more of a physical thing? So, the way I did is that airport is a entity and route is a weak entity which is formed from airport.
I would flip it around, okay, in that what are you dealing with as a company? You're dealing with routes, right? Now the routes and the beginning point and the ending point of the route is obviously an airport like you described, right? Right.
Two or many airports.
Right. But I would say that if you are looking at this, what is the company dealing with?
That's right.
They're looking at routes. They are using the airports as the mechanism about those.
But it's
Right.
not physical.
So what I'm saying is that the routes, the starting and ending points in the routes are going to have to map to some domain of airports. Right, that flights are going on. Right? But the entity that you as the company are working with strictly is the route itself. And that's because, right, when I am assigning things, I'm assigning a plane not to an airport, but to a route. I'm assigning the package to go on this particular route on whatever plane is associated with that route. Okay, right? So it's, yes, if I want to look to say, is this route possible? I need to look at the airports that I could fly to. But what I am dealing with as a employee of the company that is working with a application and dealing with the customer, right? I am dealing with what route would you like this to take? Right, right? So, right, the example I would say is if we come in and say, okay, I want this plane to go from Detroit to Chicago. Right? Certainly you're talking about the airports, but in general, when you talk to customers, they don't care what the airport is. Right? I don't care which of the Chicago airports that it's going to fly into, right? So it could go to O'Hare, it could go to Midway, I don't care. Yeah, I just want to get it to Chicago. And where's it coming from? It's coming from Detroit, right? It could potentially go out of Metro, it could go out of City Airport or something like that, right? Right? They just care, is there a route to get from this city to this city? That's in general what you publish, right? Okay. Now, technically you're right? You need to get down to that level of detail so I know which airport it's going to, what time it's going to be, all that kind of stuff, right? But we haven't given you that in the description, right? So again, you're going the extra mile, right? Okay, so all the stuff, if I'm really going to build this, needs to be there, but from what you have been given and what the company and the customers focus on, they're not focusing on the airports themselves, they're on the route.
Yeah. Just look at from a definition of entity then, mention entity is a thing, then routes, it's not a thing, it's,
Sure it is.
what is it a thing, it's not a physical thing which you can.
You're in a course right now, which is not a physical thing, right? We had, right, Cooper go ask to see his account, which isn't a physical thing, right? We have lots of non-physical things that are entities. Okay, does that make sense?
Yeah, makes sense.
Okay. All right, so we have the route, plane, and package. So, okay, so you said that, so let's run through because you guys said that we need customer. So if we were to add customer to this, where would it go?
Makes sense to put it near package.
Well, it's associated with package, right? Right, so the customer is going to bring in the package, supply the package, right, something, right? Okay, right? Okay, so if we look at package, right, and so a customer is going to bring in how many packages? Okay, so let's think about this, right? Right? Because again, this is the hard part, right? We talked about cardinality isn't easy, right? Okay, so if I have a customer that has 0 packages, are they really my customer? Right?
Could they have been a previous customer?
But that would mean that they have brought in one in the past, right?
Oh, okay, that's what you're saying.
Right, right. So a cut, right. So again, this is where you can't just go by a 2-sentence description. You have to go right. So you have a history of customers versus current customers in the last 90 days. I mean, you can break it up all kind of different ways, right? So, yes, in real life, we have to go to that kind of level of detail. In here, I would say the customer would only be a customer if they bring in one or more packages. And a package is going to be assigned to one and only one customer. Okay, so I wouldn't go with the 0. So you would have to really come up with a convincing argument for that. Okay, I see Cooper's got he's got, I'm gonna come up with one before the end of the night to do this. All right, so what about customer and route?
No relation.
Customer and plane? All right. So nothing between customer and route, you're sure?
Through a package, customer is related.
Yeah, right, so so I had, and I'm going to bring this because some people had this, right? Is they had it, and I'm making the assumption that they were saying the customer is going to ask for a specific route, right, based off of what they're doing, right? But in general, given what we know, the answer is the only thing customer is going to relate to is the package. Okay. All right, so what about package to a route? Right, so this has, right? Okay. So this has, route is assigned to a package. Everybody agree with that? Okay. And a package is assigned to one and only one route. And a route is going to have 0 or more packages. Everybody okay with that?
Did you say package will have one or many, 0 or one route or just,
Package is going to be assigned to one and only one route.
but let's say in a freight company, they will not assign a route before they do the optimization. So it will, in the beginning, it won't have a route assigned and then it will.
Okay, so here's what I see happening with you, sir. Right? On the ERD that you're going to do on the exam, you're going to spend too much time thinking about this. Okay, so again, in real life, absolutely, right? In what we've got the description, we're just kind of blasting one out, right? So you can make an argument for 0 or 1, and I would be okay with that. But in general, if you were just to toss this out to me and ask, I would say 1 would be the normal answer. Okay, but your logic of how you got there is exactly what you need to do when you approach all this stuff. Because those are all the questions you need to ask to get the real definition. Right? So all I'm trying to point out to you is don't overthink it for the one on the exam. Okay? Because yes, you could go into all kind of detail because the one on the exam is going to be more complicated than this. Okay? All right, so what about package to a plane? Okay, so plane transports packages. So package is assigned, again, so this goes back to his scenario, right? We could have a package assigned to 0 or 1 plane, right? In your scenario, or I would say a package ultimately gets assigned to only one and only one. Okay, and a plane can have 0 or more packages. Okay. Okay, and so we had package to plane, package to route. Okay, so route to package. So we said a route was assigned to a package, and when we went in that direction, we said a route can have 0 or more packages on it. Okay, and what about route to plane? Right, so in this case, we have a plane being route having 0 or 1 plane on it. Is that true? Is that a true statement based off of the wording? Each route is assigned to a particular plane each day. So, is a plane, some plane, always going to be assigned to a route? So is that cardinality right? Is a plane going to be assigned to more than one route? Yes, no, maybe,
Yes.
kind of, sort of.
Yes.
Yes, assuming multiple days.
Okay, we didn't say anything about history, so it's point in time, right? 700 routes by some of, so what's some mean? Not all, right? Okay, packages are assigned to a particular route, so again, that, right, so if I just go by that wording, it's one. Right? Okay, each route is assigned to a particular plane. Okay, what's the key word in this one?
Each
Each, and the other key word?
plane.
Right? Single, right? So not multiple planes, right? So again, you have to go by the words you have been given. Right? So in this case, it's each route. So one route is going to be assigned to one plane. Now, since we have more than enough planes, a plane can be on 0 or 1 route, but a route is going to be assigned to how many planes? Based off of the description? 1. Okay. So look at the words, and only those words. Okay. All right? Everybody okay with that one? All right, locating the, that's the intersecting streets. We don't have the things on there, oh my gosh. Okay, display the plane for a given route. Okay, so plane for a given route is 1, 2, and 3. Right, so we use those. Okay. Display the route for a given plane, right? So that's going the opposite way. So that's still 1, 2, and 3. Okay. Determining how many packages are on each route, the average number of packages per route, and the route with the most packages and the fewest. Right? So that's going to be the route and package scenario. Okay. Keeping track of the total of unavailable route assigned and available route assigned planes. Okay. Okay, so what was that one implying that you would have? That you may have a derived attribute of assigned or unassigned. Right? So again, this is a scenario where you could identify on the ERD that you have a derivable attribute, right? Because you know that you're going to use that someplace, right? Which derivable ones, you just make a determination later if you're physically going to store that, or you just know that it's calculatable and somebody is using it. All right. Keeping track of the total number of, okay, so we did that one. Displaying all the packages given a customer name. Okay, so this is where we have a customer. They have a name, and we have to make a determination of, right, so given a description, we have a customer, which is a thing. We know that that thing has an attribute at least of a name. Right? So there's times where we have to do this, right? Is look at it and say, okay, I'm not going to build the entity called customer, but I need the name attribute, so I'm going to associate with that with, or in this case, the package. Right? Because, for example, it could be, right, if you think about it, right, the customer, right, may have a different name than the person who's sending or receiving a package, right? They bring in a whole set of them to handle, right? So, you know, you could think of scenarios like, now you got me like going crazy thinking about all the things, right? Okay, so thank you. I'll get even later. Right, but that's the idea, is you've looked at this and you're seeing things that you want to pull up. Right. So, we have the name, locating the customer for a particular package. Right. So again, we're now looking for a customer again. Right. Okay, and then calculating the percentage. Okay. All right, so if we again look at this, we are dropping one of the things, in this case number 4, okay, out of this. So the plane associated with the package exists. If we wanted to know that later on, we could know, I've got all of these things built, so what do I need to do it? So it's going to be easier to do that. Okay. So we get a lot of questions once we build things on can we do something else with it? That's why you need the complete one to help you out with that. Yeah.
So for certain things like calculating the percentage of currently available planes, the percentage exists at like a different level, basically, of abstraction as compared to a plane, a route, because you're looking at all of the planes. How do you need to, or how would you represent that on a complete ERD or build?
You don't necessarily, right? Because what that is what you're looking for in the specifications is that not necessarily this is something that you are going to have to store someplace, right? But it's something that you derive this, right? So you are either going to add it as a derived attribute somewhere in the ERDs, or because there's just so many of these, you don't put any of the derived stuff. So in general, right, if I was to depict all of the derived things that I put on screens for the people in the business centers and all kind of stuff like that, right, my ERD would probably double in size from my attribute perspective, just because we calculate so many different things and put them on dashboards and all kind of stuff. I mean, it's just, right. What you're trying to do is to say, given a specific requirement, is there a way to get what the customer is asking for from the data that you have? So, as I say, I've only been at one company where we put derived, and there was a really small percentage of the one. So it was the scenario is if you derived it and you stored it.
But then whatever you're storing it in would be at like a different level of abstraction, basically. So it would be potentially stored in a separate database.
No, you picked which database to put it on. Right. So in this case, you would have to pick one of the attributes to put the derived piece of data on for availability. So you would put it with a plane, for example, if you want to. Okay. All right, so you guys all had that, or pretty close to it? Okay. Okay, and so Mark, since you picked on me, I'm going back to you for the next one. All right, so in this one, we had the user is the manager of a large taxi cab service. 700 cabs are manned by about 1,400 drivers on 2 shifts. City of operation is divided into 900 square areas. How nice. It's nice and square. Each consisting of a number of streets. Streets are straight and run either east or west or north-south. Street may be in more than one area. Street names are unique. Each driver is assigned to a particular cab and area when they arrive for work. Driver reports to the dispatch by radio upon pickup. Cab 47 in use and delivery of customers at their destination. Cab 47 available. The driver also reports area changes. So cab 47, area 13. So let's see what Mark came up with. All right, so Mark has driver. Everybody have driver? Okay. And vehicle, cab, something like that. Okay. Area. You guys all have area? Okay. Okay. Intersecting. If that area is marked.
So, areas, and then it's comprised by intersections.
Okay, I can't read the last word down there, so. All right, so, anybody have anything else? Yeah?
I think there's an argument for drivers being slightly broader because dispatchers are also mentioned in the problem statement. But I think that there's perfect justification to go for driver as well.
Okay, so you had dispatcher?
Well, employee with an
Employee.
employee type driver or dispatcher.
Okay.
I just think there's an argument for that.
Well, right. What was the description? The driver communicates with the dispatch, assuming there's a dispatcher, because since you're talking, somebody should be hearing, so we can take that leap of faith, right? So I would say that you do need a dispatcher, whether it's the same as an employee, right? I mean, that's up for debate later, right? So I would say that dispatcher also needs to be on here. Okay, and anything else?
Street,
Streets?
city, area.
I don't think city necessarily, right? They're assuming a city, right? So again, don't overread it. Right? Okay. So, but streets, I would say streets for sure,
Area.
right? So he's got area up there.
I
Okay.
think intersections is interesting actually because streets can span in the middle, but an intersection seems like it would only ever be in a single area.
It is only in a single area.
And so my thought with this was with the problem description, the location of the area, was the way that it was discussed in the problem statement was that it was basically a point. So it was, the intersections were used as a reference point for an area. And so if you think of it as a series of points, then the intersection would be good enough. And then intersection itself would be, have key fields of your northwest and east, or your north, south, east, west streets. That's the thought.
Okay, so again, the scenario is that the person who is doing this modeling is making some decisions about what it means and how it works. Right? So the fact that Mark has this may or may not match your interpretation of it, and that's okay. Okay, but I think something else is missing on here.
Relationship between,
No, not even really, I'm right to really, I'm talking about entities still.
Cap,
Well, that's kind of the vehicle. Customer, right? We had customer in the last one. You know, what do you call it? Customer, passenger, something like that, right? Okay. Now, are you necessarily collecting all the data on the customer? No, but are they part of your business? This is something that you potentially may need to talk about in the future and how they all interact with the system. You're modeling the system, the entire system. Not just part of it. You're looking and saying, what are all the things that this company, this organization, this system is dealing with? What is possible? Then you're figuring out what you need. Okay? So we didn't have anything where we were recording about, right, any data about a passenger, but do they exist in what we're dealing with? The answer would be yes. Okay, okay? So I think if I was to do this, passengers would be there, right? I would also have dispatcher on here, and I would also not have intersections, but I would have streets. Okay, that's what I would say this up. Okay, and Mark, you were talking about a relationship.
yeah, the driver, both driver and vehicle should be related to intersections, or if you have a street entity, put it in street.
Right? Because those exist, right? Again, you may not use them, but do they exist? Okay? So, just like the driver and the cab or the vehicle is in an area, they are also on a street. So again, what is the way that we do this? You pick whatever the entity is and you walk to every other single one and say, is there a relationship between these two? Yes or no? If there is, you draw it. If there isn't, you don't. Okay, so who is the dispatcher going to interact with? Driver. Does the dispatcher interact with a vehicle or a cab?
No.
No. Interesting.
All cell phones.
So let me ask this. So is the dispatcher concerned with the driver or the vehicle?
Both, the union of.
The union of, right? So if it's, you are concerned about both, then there's a relationship to both. The dispatcher needs to know the status of the cab. Not the status of the driver, the status of the cab. And they need to know where the cab is located, but that's also where the driver is located. Right? Right. So again, you need to think of all the kind of pieces of this. So I would have the dispatcher interacting with and wanting to know about the vehicle or the cab and also interact with the driver. I would also have the fact that the driver is associated with the area and the street. And what about passengers? Passengers are associated with which things?
CAD, street, area.
Kind of all of them, right?
Yeah.
Right? Right? So, right, we've added, right, so this was the longest one where now we have probably 10 sentences and now we're getting building, right, a pretty complicated ERD on a relatively small set of descriptions. Now think about interviewing 40 or 50 people for a couple of hours each to figure out what everything they're doing and then trying to put it all together into one. Right? That's why this all takes so much time. But what happens if you have a complete ERD up front?
Everybody wins.
Everybody wins because you've only had to do that work once. Okay, so again, I'm not gonna take you through all of it because we've been through a couple of them, but you get the idea, right? So none of these, except for the, right, we went through, had the complete equaling the built. They all had, actually, especially the last two, we had customer and passengers that we're directly not getting any data about at all, but they're part of our system. Okay. So in just scanning what you guys have turned in, because again, I haven't gone through these in any kind of detail, right? I think all of you, the ones I have seen, all look really good for the very first time that you're doing this. Right? Because if you already knew how to do it, you shouldn't be here. Right? And so, can we improve? Absolutely. Are you going to improve? I'm sure you will, because I've already told you it's going to be on the exam. And are you going to have to draw a complete and a build on the exam? Yes. Is it going to be more complicated than this? Of course. Right? And you're not going to overthink it. Go with the words that are in there, right?
Yes.
Yeah. Right. Okay. So if you interpret it one way and I see what it is, it's okay. Right? But I will not take that, oh, I completely thought that this was completely different and you draw something way out that I can't. If I can't see it from looking at it to what the description was, then it doesn't work. But if it's close, we're okay. All right, so any questions on this? So again, there is not a one single way to do this. Right? So if you didn't have exactly what we talked about, it's okay. Right? So Mark's example of the intersections, that's the way he interpreted it, right? City planners always think differently than the rest of us, right? But again, it's his background has played into how he's interpreting this. Right? And the detail that you think about it is going to be as his example, right? He was thinking about it in very specific terms and steps. We all think about it differently. Okay? But this is a model. What's it a model of? Everything that is possible, followed by what is it I need to build to satisfy a set of requirements. And what's going to happen next? You're going to, after you build this, there's going to be somebody else who's going to ask for some kind of change, and you're going to need to come back and say, can I get whatever the data is out of what I already have to give them what they are asking for, and do I have it built already, or if I don't have it built, is it possible to get it? If it's not possible because it's there, then I have a lot more work because I have to figure out how to go about doing all of that. Where if I just go, oh, it's just something I haven't built yet, but the relationship exists or the entity exists, right? Now it's just how to figure out the mechanism to get that data, because it's already part of the system. All right? Any questions? So like I said, great job for the first round of this. Okay. All right, so Cooper and Kendra right there already alluded to what we're going to be talking about today, because they're so psychic about what we're going to talk about that they wanted to include it in theirs already. So I was actually going to ask them if they want to come up and talk about this instead, but I'll do it just because I don't want to torture them in this way. All right, so this is the idea that, so extended means that we have to look at things in different ways. And what we mean by different ways is the idea that we end up dealing in real life with the idea of subclasses and superclasses. I don't like the wording for that, right? Because this is really technology type of terms, right? Classes, right? It's in real life we have hierarchies, and the hierarchies exist because of the structures that we have within organizations. Because we have literally categories, so we have higher level categories, we have lower level categories, right? We break things down in different ways, right? So the idea is that when we're talking about our extended relationship diagrams, is we are including those as part of our description. And we put it in there because there is some reason to put it in. You don't put it in for everything, right? Because it could be, if these subclasses, for example, right, you may only need to have, in this case, we have the example of an employee maybe further grouped into secretary, engineer, technician, based on the employee's job, right? So in this case, you have to make a determination, is there something different or unique about these different groupings that are going to cause you to do something different? If there is nothing different, a simple attribute would be employee job, and putting their title of secretary, engineer, technician into that would be good enough. Right? So again, it's what is differentiating all these, because I literally don't want to have a subgrouping for every possible thing that I can break down into subgroups. It makes no sense. Right? Okay, we have a manager, so we talked about this. There's our kind of unary relationship back to, right, the employees who are going to manage other employees. Okay. Okay. We have an employee can either be a salaried employee or an hourly employee. Right? So, right, things that are the way that they're, for example, going to get paid is going to be based off of which category they happen to fall into. So our extended diagrams, right, represent these additional ways of classifying things. Right? So if we were to look at this one, right, we have employee at the top. So we have, what can you tell me about this one?
All engineers have social security numbers. Apparently.
That is true. But what about technicians?
They may also have social security numbers. It seems like all of them do.
Well, Cooper, I hate to tell you this, but they have to.
They have to.
They have to. Not they might, they could, it's they have to. Right? So, we have employee at the top, right? And social security number is the primary field that is uniquely identifying those. We already said that that's a really bad one to pick, but they do anyway. Right? Okay. And as Cooper would say, they were born on some day because they have a birthday. And they have an address and they have a name, but the address is one giant field and name is broken up into there's categories of first name, middle initial, and the last name. All right, so if we were to look at this, right, beyond the secretary, the technician, the engineer, and the manager, and the salaried employee and the hourly employee, all of those having a social security number required, right? Okay, so what is this telling you? This is telling you that none of the lower levels can exist without the top level. So you have to create the employee before you can create any of the other ones. Right? Simple as that. Okay. Okay. So we have the wonderful little letter D's in there. So what does that represent? Those are just kind of groupings, right? Because we know, right? We have 3 different groupings that are appearing under employee, and we have secretary, technician, engineer under one set. Okay, and in this case, we have a single line going over to the D, and we have the lines going underneath to secretary, technician, and engineer. So, and if we look over on the other side to the other D, we have a double line. Right? And that's to salaried and hourly employee. Okay? So what's the difference between those? On the left-hand side, it says the employee might be one of those. They don't have to be one of those. They can be one of those. The one on the right side, where it's the salaried employee or the hourly employee, right? You have to belong to one of those. Right? So you're saying that that relationship is every single one of the employees is going to be assigned to one of those. Where, as we said, the other side, as well as the manager, they may or may not be. Okay. All right, so what else can you tell me about this? So kind of we inherit things out of this, right? So that's the whole idea of the classes, subclasses, superclasses idea, right? The inheritance that you guys probably did back in your programming classes and stuff, right? Okay, so we have a secretary with a typing speed. We have a technician with a technology grade. We have an engineer with an engineering type. Right. So what's that telling you? Those are unique data fields or attributes to that particular instance. Can you have a piece of data that's on multiples of those? Sure. Yeah. Right. Okay. But you put it down in the second row or second level if it doesn't apply to all of the employees.
So what is the implication of having the must then? Because that suggests that it must apply to all employees.
But you have different categories. And the different categories have different pieces of data. Right? So the way that you want to think about it is, do I have to have this kind of breakdown at all? No. So I can, if those are the pieces of data that I wanted to keep track of, on the employee, I could have an attribute called typing speed. But it only applies to secretaries. I happen to be at sloth typing speed. Okay, then the T grade is only for the technician, but that certainly could be at the employee level. I could have salary and pay scale, right? So I could have those, right? But what do you know about salary and pay scale when you put them on an employee? Only one of those for each employee is going to be filled. So that means the other one is empty, right? And if you have 200 employees, that's probably no big deal. If I have, right, historically, and I keep everybody's record, and I have, right, several million worldwide overall over the history of the company, your storage of empty spaces can add up. So I have to keep track of these, right? So this is where we kind of get the trade-offs, right? So we build this picture, because what does this picture represent?
Employees.
This is the picture of employees, right? This may or may not be how we physically create it, because this is the way we want to logically look at it. Now, in general, you want your complete ERD to be kind of break down to this layer, but when I actually do the build, I pick pieces out of this, and then we have to translate this into what are we physically going to build, which may be different because I have to combine things together sometimes. Okay? So again, kind of the idea of this is you're trying to identify how much data is different. Because again, if there's not enough data difference, I'm not going to want to create a whole separate build process for these other pieces and the overhead of accessing that, because it's not going to be worth it. But from a logical perspective, this is what it ultimately looks like. Okay, so each of the subgrouping is a subset of employees. Each one is a subclass. Employee is the superclass because it's the one at the top, right? And right, we have the different relationships that we have between those, right? So we can call out each one of those. Okay. Okay. So these are what's called a relationship, right? So secretary is a employee, a technician is a, right? Okay. And you can read it kind of the other way too, right? Employee is a secretary, right? So again, you should be able to read it both ways. Okay. So this book reads it upwards. A lot of them will read downwards, but it means the same thing. Okay. So an entity that is a member of the subclass represents the same real-world entity as the member of the superclass, right? Because you can't have a subclass entry without a superclass. So it's kind of that weak entity kind of thing. You want to think about it that way? Okay. Okay. Right? So it's a same entity in a distinct specific role or category that we identify. It can't exist in the database by a member of a subclass. It has to be a member of the superclass. So in our example, you can't have a technician by itself. There has to be a technician associated with the employee because you need the data at the top layer. Okay? And a member of the superclass can optionally be included as a member of any number of subclasses. So in our example, right, back here, what could we have? We could have an employee who is an engineer, who is a manager, and they are a salaried employee, so they can be in multiple categories. Okay. Okay. So we can also set up that they can be in one and only one. Right. So there's different ways that we can identify the way that works. Okay. So as we said, a salaried employee who's an engineer belongs to two subclasses: the engineer and the salaried employee. Salaried employee is also an engineering manager, belongs to the manager, engineer, and salaried employee, right? Okay, and you can have an employee that doesn't fit into any of those, technically, right? So if we didn't have the double line that said you have to have that relationship, right? So if they were all optional ones, you may have an employee all by itself.
So why do we have a separate manager line there?
Hmm?
Yeah. Why do we have, why can't we combine secretary, technician, engineer and manager under that?
Right, I didn't hear a question, sorry.
Why can't we combine manager under the category of, like technician and engineer?
Because what you're trying to state here, right, so we're not, you're trying to, because, so let's take a step back, right? If we look, we have 3 different categories here. And you have to look at them uniquely, right? So, the scenario that we have is that we have this optional domain of values over on the left-hand side that is secretary, technician, and engineer.
So
Right,
you mean to
right.
say that there can be only, an employee can take a role of either a secretary or a technician or an engineer?
Or something else.
And maybe an engineer and a manager, or just one of it?
No, so so take it into the 3 groups. Look at them completely independent,
And only one out of the
right? So if you look at the left-hand side, you have secretary, technician, and engineer, right? And there, we just have a single line over to the domain that's there. That says an employee may be one of those 3, but they don't have to be, right? So they could be something, they could be a scientist, right? We don't have a scientist category, right? But they could be one, so they may be one of those 3. But they might not be. Right? So if they are one of those 3s, they're going to be assigned to that category. Okay. Now, the employee could be a manager, right? But being a manager, they don't have to be a secretary, a technician, or an engineer. Right? They could be right? They could be the manager of the scientific group. So it doesn't fit under there, but they could still be in that category. Okay. So we separate those out because you're looking at those as independent things that they could be. Right? So if I put manager under engineer, technician, and secretary, I'd also have to have one outside of that, which doesn't make sense, right? I want one definition of here's a manager, an employee can be one or not.
So what I understand it can take just one of the 3, right? One of the 2 groups.
Nope. So you,
So an
you,
employee can be an engineer and a manager.
yes. Right. Right. So you have 3 groups here, and the only one that they have to be is the one on the right. So every employee, right, is distinctly a salaried employee or an hourly employee. So that one's a given. The other 2, because they have single lines, are possibles. So I already have them assigned to one, and now, are they a manager, yes or no? If they are, they're going to manage, in this case, some project. Okay. If they're not a manager, that doesn't exist in the way that we look at them. If they are a secretary, a technician, or an engineer, they're going to be a one of those, and we'll be able to follow that path. If there's something outside of any of those 3, they still can be an employee, but they're not in that category. So you could, as we saw in our example over here, right? A salary employee who's also an engineer is going to be in the engineer and a salaried employee. So they're in 2. If the salary employee is in engineering manager, they're going to be in manager, in engineer, and a salaried employee. And, right, if we go back to our scientist, we don't have a category for that, so they're not on the left side. They're not a manager, so they're not in the middle, but because we said they distinctly have to be one of the ones, they're going to be a salaried employee, for example. So in this case, you have to have one, you can have up to 3. So, did that answer your question? Okay.
So one question, do we have the slides in the files? I'm trying to look for that, it's not, this slideshow.
Mm-hmm.
Is it in the, is
On
it
the
uploaded?
slide.
Is it in the Canvas?
I am betting that this is sitting out there unpublished. How's that? That's my guess. All right.
I take notes in the slides, that's why I was trying to look for.
Oh no, I'm don't want you to be mad at me for anything. Let's go back over here. All right, close this out. Look, unpublished. So we'll publish it so you can do that. How's that? So I apologize for that. So thank you for asking. All right, so right, our diagram for attributes. So again, this is just a blowout of that one particular one, right? Okay, right? So if we look at this, the only thing that they had literally said is if we look up here, we have job type on the far right-hand side. And they're saying that the line down here is associated with that job type attribute. Okay. And if we have secretary in that particular field, it's going to go to the secretary. If you have technician, it goes to technician. If it's engineer, it goes to engineer. If it's anything else, we don't go anywhere. Right? So all this is doing is giving you the fact that that line is representing that piece of data or that attribute. And what is the exact data that is going to drive you to go down that relationship. Okay, so as we said, entity that is a member of the subclass inherits all the attributes, right? Because they can't exist at the lower level without the existence at the top. Okay, and all relationships, remember, so right. So in our previous slide, the secretary as well as technician engineer inherit the attributes of name, social security number, and all that stuff from the employee. Okay, and every secretary entity will have values for all of the inherited things. Right. So again, you have right. The employee has to exist. Whatever data that is requirements and the constraints that you have on it are going to be in place. It has to exist before you can create the subclass entry associated with it. If I'm going to delete it, I have to either delete them all at the same time or I have to delete these subclasses before the superclasses. Right? So we have different ways to deal with that. All right, so the way that we want to think about it in the terminology that you will typically encounter is generalization and specialization. Right? So specialization is if I'm traveling down because I'm getting more specific. And if I am at the lower level and I'm going up, I'm generalizing because I'm getting the data at the higher levels that are more common across the board. So a specialization process is defining that set of subclasses, right? It's based on some distinguishing characteristics, right? So again, right, not only do we have to have our example of secretary, engineer, and technician, right? But you need some data that's different. If I don't have any data that's different, you don't create these subclasses. Okay? So a manager, as we said, is a specialization of employee based on the role, right? So again, this is a role. An employee is also a manager. So again, we can have different specializations. So in our last case, we had 3 different specializations. We had secretary, engineering technician. We had whether they were a manager or not, and the type of employee is salaried or hourly. Okay. So another specialization based on the method of pay is our salaried and hourly. Okay. So again, our relationship and specialization is based on our representation. Right? The attributes are called specific or local attributes. Never heard it termed that way, but the book talks about it that way, so it's really nice. Right? Okay. Okay. So typing speed is the attribute of secretary. Right? And the subclass can participate in a specific type, right? So oration belongs to. Right? Okay. So we had ISA before, and now we have belongs to. Okay, in our scenario, right? So if we come back to our example, right? So again, we had the idea of what's at the top? Superclass. We have at the second layer, we have the subclasses. What we're saying is the subclasses can now have relationships to other things. So just like we linked in the example which you had before to, right? So the plane and the package and the route and all that kind of stuff, those are all entities, right? Well, I may only link to one of the subgroups and not to all of these. So in our diagram, these are now acting as individual entities as well. So in our case, the hourly employee belongs to a trade union because that's a relationship. So trade union is the entity. Hourly employee is an entity, even though it's a subgroup of employee. And the hourly employees are the only set of employees that belong to the trade union. So again, the relationships aren't always to the superclass. They may apply to the subclasses. Okay, so as we said, generalization is the reverse of the specialization process. So several classes with common features are generalized into the superclass, right? And the original ones that we come up with are the superclass because we don't divide them up till we know that there's a higher level entity that we want to deal with, right? So, right, we have car and truck can be generalized into a vehicle, right? And then because we generalize upward, we can then say that car and truck are the subclasses or the specialization of vehicle, right? So again, you can read it both ways in the process. Right? So in our example here we have car and truck having a set of attributes, so we kind of draw them out individually, and then we look at those and say, all right, so if we are going to generalize those, what do we have for vehicle ID, price, and license plate number? What do you know about those? Those appear in all vehicles, right? So if I look at car, they exist. I look at truck, they exist. So they are going to be the common things that are going to be at the top in the superclass. And the max speed and the number of passengers for the car, and the number of axles and the tonnage are associated with truck. Those are unique to those subclasses, so we leave them with the subclass. All right, so we have some different ways that we diagram these things, right? So we have arrows that go all over the place, and right? Okay, so what is now happening? They're taking these things and they're turning into like all kind of different things, different ways to interpret them, and now it's too much work. It's already been too much work, right? So the idea of this, when we start looking at it, is if you put too much stuff on a single diagram, it makes it completely unusable. So what do we have to do? You break it up and you have lots of diagrams. So what's the good news about that? It's easier to use the individual diagrams, but now you have to keep all of the diagrams in sync with each other. And what was the cool word that we had for about keeping things all in sync with each other? Traceability. That's Mark's favorite word.
So I'm down
Yeah, in my other classroom, he was going to get a tattoo with that on it. So
Still working.
I'm still waiting for it though. All right. So again, we have arrows that point which way and what kind of groupings they are, of whether they constitute the whole thing or the ratios. Okay. So when we talk about data modeling, right? Think about real life. We have lots of things in real life that we have categories of. And we do want to know about those. Right? So we need to take time to identify what we need. And there's times where we put things on and we take them off later just because, right? Right, in our example here, okay, I want a secretary and I want a technician and I want an engineer. I don't really need those later on, so we go through iterations when we build these things of putting things in, taking them out as we work our way through. So just like you guys said, right, if we went back after we talked about today, there's probably something that you would make a change on the ERDs that you did based on what we talked about. Right? We go through iterations like this all the time, right? So the scenario is that we want to draw it all out and then decide, right? We go through, right? Okay, so our data modeling, right? So our superclass or subclass represents our collection or grouping of these entities, right? So again, there's times we just brainstorm all of them out there and then you have to decide which ones that you're going to do, right? They also represent a particular type of entity, right? We are showing them in rectangles just like the regular entity types that we have. Right? Okay. And we don't necessarily call them out, right, directly, but because they're on the diagram that way. Okay. So the different types of specializations that we have. Right? So the first one is the what we call the predicate defined or condition defined. So it's based on some predicate. So our example of our attribute of job type, age, something, right? So you're picking a category and then based off of that, you are then going to fall into one of the subclasses. Okay. We have attribute defined, so it shows the name of the attribute next to the line. So we saw that one with the job type in the exact wording that you were looking for, right? And then we have user defined, where the membership is defined by the user on an entity by entity basis. So as something comes in, you make a determination or classification or something and you put that in and it's determined off of that. Okay.
When you say attribute defined, is it like the typing speed?
No, so the attribute definition would be if we went back and looked at this one, right? So on the line itself, you specifically state that that line is representing job type. And then, right, so job type is the attribute, job type is on the line. The secretary, technician, and engineer are the data that would be in that attribute that would cause you to be in that category.
So you call the,
So you're specifically calling that out on the diagram itself.
okay, so is that the job type or do we call the secretary the attribute? Or,
No, so job type is the attribute, because if we look at the top, it's listed as an attribute on the top, right? Okay, And what you are saying is to determine if where you are below, you are specifically looking in the job type for those particular words. I want to call that out directly. Okay? Where the other one is we said that it's data in the attribute. Okay, so it's based on some predicate, in this case, I have to say job type, but we didn't call it out directly. You don't have the example on the line, you don't put the attribute name itself, right? And so we didn't have that, right? You didn't put the words secretary, engineer, technician, right? So you didn't call it out, but it still could be based off of that. So in one case, in the attribute defined, you are specifically saying which attribute and what are the values associated with it,
Like secretary or
right?
manager.
Right? And in the predicate one, you're saying, yes, it could be based off of the attribute, but you are not defining exactly what that is on the diagram. Right? So when we went back in, look at this one, right? This would be the example of the predicate type, because we don't have any value on the line down here. Right? We don't have secretary, we don't have technician, we don't have engineer. Right? Okay. We don't have job type up here. Right? But we know an employee is going to fit into one of those categories, or could possibly put into one of those categories. Right? In the other one, we said there is specifically an attribute. We added the attribute up here called job type. And then we put that on the line. And then down here, we put exactly what was the wording that would be associated with that. Okay, does that make sense?
Yeah, it's very subtle.
Yes, it's a very subtle difference, right? Now, my argument would be is I would say that this would be wrong. This diagram would be wrong. Why would, knowing what I've just said, why would I think that this is wrong?
Secretaries don't have addresses.
Okay, Cooper, you go back to sleep, would you? Okay. My argument would be is that this represents all of the data that you have about each of these entities. So I would say that even though I don't have the line there, or don't have the name on the line, there should be job type up on the employee. Because it is something that I'm keeping track of, right? This does not tell me directly, in my view, this doesn't tell me directly that there is a attribute called job type that is going to drive me to one of those things. Yeah.
So, what does the D represent?
The D is just representing a grouping.
So it's nothing specific?
Yeah, so the D in our example says, right, it's just, you want to think of it as more like a connector.
Could it be anything else?
I would let you put in whatever character you wanted for that.
Okay, that's what's confused, like, if it had a specific.
Yeah, so there's actually a D and an O. Right, okay,
Yeah.
right.
So what was?
So, yeah, and again, it's, books tend to overdo what we do in real life. In real life, I've never seen a D in any one of these diagrams. I've seen a circle like that that says, okay, this is a connecting point out, right? But they put in all this extra stuff, and when they put in all this extra stuff, nobody wants to do it because it's too much work. Right? So the D is just representing, it's a collection point. I get there, and then here's the possible outcomes that I have.
One question on, going back to the other one. So.
The other one, there's so many other ones I could
Sorry,
go to.
I'll explain that, the attribute based and the predicate defined.
That one?
Yeah, so like you said, the employee can have an attribute called job type. Given that it has an attribute called job type, I don't see the need to do, the example that they have provided here is not a good example, at least that I'm looking at it now from a predicate defined and attribute defined. So when you, can you say some real application when you would really do that sort of a thing?
All right, so, I mean, actually, we do break down employees like this. So this is a
But
typical,
both, you can do both ways, right?
Right.
Why would you do?
well, if you take a step back, right, what the employee can be is not different in either case,
Right.
right? You either you fall into the secretary category, you fall into the technician category, you fall into the engineer category, or you fall into kind of the other category because you didn't fit into any of those,
Right, yeah.
right? And in this particular case, we are saying, by directly looking at this, we have an attribute called job type. Job type is going to determine which one of those you fall into, and if you are secretary, technician, or engineer, you're going to fall and have a subclass, otherwise you are not. That's what that tells you. Okay. In the other example, where we have this,
Yeah.
right? This is indirectly telling you that there is a job type,
Right.
right? Which it really, my argument is, I really should have that to tell me I have that as an attribute no matter what, right? But the way that they're describing it, job type is implied, and job type is going to determine whether you fall into secretary, technician, engineer, or other, right? So in the end, the result is exactly the same thing.
Yeah.
It's which way are you going to describe it that's going to make the most sense?
Right, yeah.
And to me, it's neither of them. It's, you take this, you add job type as an attribute, and we're done,
That's right, yeah.
right?
You don't have to do this.
Because then I don't have to worry about what is the exact wording. I should be able to tell from this that job type falls into the secretary, technician, or engineer. If I can't figure that out from looking at this, I shouldn't be looking at the diagram at all, right?
Yeah,
But it also tells me that there is a category or an attribute that is called job type that we can then use.
okay. So in
Right.
other words, if there is an if there is no attribute which you can really think about and you still want to categorize it, then you can use
Yeah.
the.
Right? Because this is implying that, oh, there's attributes that I don't list there that are really existing. I want to look at this and see what are all the things that exist.
Right.
The
Yeah,
other one, it's way too detailed that I have all this stuff that I have to identify. It's on this line, it's this attribute, and here's the exact values that are going to drive you to that. Yeah, that's too much work. Right? I don't want to do make work when these are hard enough to do as it is.
right, yeah. If you don't know the attribute, then yeah, like you said, you cannot really create that.
Yeah. So the one I like is not either of these, but it's a combination, sort of them.
Okay.
All right, any other questions? All right. Okay, so constraints, okay? So if we can go exactly, these entities can become members of the subclasses by a condition, right? Okay, so again, our condition was based off of having a given set of values, right? Okay, so we can put the precondition on the line associated with that. So again, we saw that in our list of, it has to be the word secretary or the word engineer or whatever it is, right? So what's the value that you're gonna have? Right? If all the subclasses in a specialization have this membership condition on the same attribute, it's called attribute assigned. So we just talked about that. Okay. If no condition determines membership, it's called user defined. So again, it's right. You would set something that would cause it to happen, right? So it could be a range of values, and you are just determining what it's going to be, right? Not something that is very specific, right? So we have those kinds of things where you, for example, you come in and you specify when you receive a package what type of package it is, and you just identify it by the user typing in the type it is rather than an exact wording, something like that. Okay, so again, our attribute defined one was the example that we had of the job type attribute matching all up that we've talked about to death here. So, all right, so there's two basic constraints that we can apply, and it's disjointness and completeness. How good is that? Okay, okay, so disjointness specifies the subclasses must be disjoint. So an entity can be a member at most one of the subclasses. So that's that D that we talked about. Okay, so the D says you can only be in one of the categories that fall out from the D. The O is for overlapping, which means you might be in multiple categories. Okay. So that's all that's trying to help you by looking at it determine. Okay, so there are other scenarios, so again, kind of other representations of if you, so for example, if you don't have that kind of D versus O, if you have, for example, a nice arc that goes through them that can indicate that you can only be in one and only one of them. If you don't have the arc, you can be in as many as you want, right? So again, there's not a set standard way to do that, but the way that the book is outlaying it, they have the D, which means disjoint, saying you can be in one and only one of the categories. The O would represent that you can be in multiple. All right, so the other thing we have is completeness or exhaustiveness constraint. So the total specifies that every entity in the superclass must be a member of some subclass in the specialization generalization, right? So again, that's our double line that's taking us to the salaried hourly part, right? So you have to be part of that. You don't have a choice. Okay. 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 So partial access means you don't have to belong to any of them. So again, our partial was the secretary, engineer, technician, right? So you could be in one of those. It had to be distinct or disjoint. You could only be in one, but you don't have to be in any of those. What about manager?
Overlapping.
Overlapping?
Yeah, they said you could be a secretary manager.
I so like you, Cooper. Right. So Cooper is correct in one sense and not in another. Right. So, two favorite words? It depends, right? Depends on our view, which is true or not. Right? So in the example, right, where we had our disjoint set of secretary, technician, and engineer, right, you could be one of those or none of those, and it would be okay. And we listed it with a D because we were considering that as one distinct grouping. So that gets back to her question earlier about what you can be in, right? So, right, and we were looking at disjoint being that one unit. Now, I'm sure this is what Cooper was thinking, that if we go kind of up a level and our grouping is that group of three, the manager and our salaried, you can be overlapping because you have to be in at least one, but you can overlap into either of the other two. So depending on what level that you are looking at, you can make an argument. So, right, so in the example that we just gave, so Cooper, thank you for this, right? So in the example where I would say, right, is manager overlapping, I would be looking for you to say no, because we don't have the indicators, not part of a group. But I never allow yes or no answers, right, Mark?
It's true.
Right? You're gonna write a lot,
Yes.
right? So why or why not, right? And if Cooper explained, it was because, well, you could be in these, and so his explanation would be, I'd have to give him full credit for that. It would be hard, but I would do it. All right. Okay, so our partials are the single lines, the completeness is the double lines. All right, so we have 4 types of specialization. So disjoint total, disjoint partial, total overlapping, and partial overlapping. So what does this look like, Mark? This looks like a test question where it would be, give me what it means and give an example. Something like that. What a great test question that would be. Oh wait, look at how you all like kind of wake up at when I say that. It's pretty cool. Okay. Okay, so again, generalization is usually in total because obviously these superclasses derive from the subclasses. All right, so again, we go back to our example here. So what does the single line mean? Partial. Right. We're dealing with that. Okay, so now this is overlapping, so why would it be overlapping? Or what would this be telling you? Wow, this would be another great test question. Given this diagram, explain what it means. There's so many opportunities here. So what's this telling you?
Would the entities have a necessary and like manufactured part and purchased part have to have part?
Right, so the part has to be manufactured or purchased, right? Everything has to be one of those. Okay? Okay? But what else does it mean since it's overlapping? It could be both, right? So I could be making internally that one, but I may also buy some of that same thing. Right? So if I was to put this on the exam, sorry to keep you up, right? Okay. If I was to put that on there and say, explain this to me, you would say, what? We have an entity called part. It is uniquely defined by a part number. It also has a part description. Right? And the part has to be either manufactured or purchased. If it's manufactured, there's a drawing number and a batch number and a manufacture date associated with it. And if it's a purchase part, I have a supplier and a price. Okay. And how are these all linked together? what links all these pieces?
Is, well, just the manufacturing parts of the part.
The part number is what is linking them together, right? So we don't specify down at the lower level that part number is linking them together because we know it because of the relationship that we have drawn.
So the key of the superclass is also the key of the subclasses.
Yes. And what does it mean? Since it's the primary key, that's unique. So there is one entry for that particular part at the part level. There's only one instance of it at the manufactured level and one at the purchase level. So what would happen if I had a situation where I had multiple purchase parts for the same thing? So multiple suppliers. Right, that exists.
Different part numbers.
Composite key for part
I don't want different part numbers because then I really mess up because, yeah, right? No, what can I do? Composite key.
Sure, composite key.
Excellent, thank you, Cooper. Right, so a composite key, so I could have a part number and, right, supplier name could be a combination that would make it unique, right? Because if I am going to the supplier and I'm paying different prices for it from the same company, I got a different problem. But we've seen that before too. Right? So any questions on this?
Wait, so then what would the composite key be? Would it be the suppliers?
Right, so you have to, if I'm going to have multiple instances of the purchasing side, because I have multiple suppliers, I need something that is going to make it unique, right? Because I have multiple entries for it. So part number by itself is not going to be enough. But I have to have part number because that's what the key at the superclass level is. Right? So I have to have part number, but I also need something at the lower level, so I have to pick something. Well, price doesn't sound like a good choice.
Okay, so you wouldn't like make up more keys? You would define one of those attributes and make that a composite key?
That is your preference,
Okay.
right? Now, we have scenarios where we have system-generated keys just to make stuff unique, but I don't want to do that here. Right? Okay. But you could. But in general, you try to avoid those if you can. But great segue for stuff that we'll talk about later. So thank you. All right, any other questions on this? All right, so subclass may itself be further subclasses, right? So we can have a entire hierarchy of these things, right? So subclass can only have one superclass, right? And you basically create a whole tree structure out of this, right? So as we talked about, right, in just a general hierarchy, right? Because we don't try to do any of this lattice type of stuff where a subclass can have more than one superclass and have multiple inheritance and all kind of stuff like that. Right? This is like way too complicated, right? But just doing the straight hierarchy, some of ours are 15 or 17 levels deep, just breaking the stuff down. And now you want to add on top multiple inheritance to other groups. Okay, so what was the, okay, this is a trivia question from earlier in the class. What was the first type of database management system? Starts with N. Network. Oh, look at that. You think you're going to get that on the exam, do you? No. I'm giving the first letters of stuff. I could. And when you don't know what it is, I get a really great answer. And so network, right? So why wasn't network like really popular? Because they tried to do all this multiple inheritance stuff, right? You had multiple parents and trying to do all kind of stuff. It just got way too complicated, and you have so much overhead. It's so slow you can't manage it. Right? So they talk about it in all the textbooks, but we never do it in real life because it is just too complicated to manage effectively. Again. Right. So, right, we had the employee, and they could have a manager, and we can get the engineering manager from 3 different scenarios. It's, oh, how do we get this, and how do you manage it? And right? So, this may be true. It absolutely may be true, right? And I have yet to see it depicted, but other than the textbooks, but yes, you could draw it like this because it's logical. But if you went to actually build this, it'd be really hard. Because the database management system would have to manage all this, right? And what happens when I'm trying to get the data in all these different ways? And if I try to update the data in different ways? And what if 2 people are coming at it from 2 different ways, right? You just have lots of complexities that we want to try and ultimately avoid. Okay? So, do they exist in real life? Yes. Can we depict it on some logical picture of this? Yes. Would you ever build one? Absolutely not. And if somebody asks you to do it, you just say no. Okay? Simple as that.
They pay you a lot of money.
Huh?
What if they offer you $1 million?
Well, when they come back and sue you for like $12 million because it doesn't work very well, it probably doesn't sound like such a good idea anymore. Just saying. Right? Because usually they want a guarantee of how fast it's going to be. This isn't going to do that. Yeah. All right. So in this lattice or hierarchy, right, it's not only this direct superclass, but all of its ones. So you get them all together, and it's all great. And you tie them all up, and nobody can update anything because you've locked up the entire world. Right? Okay, so we have shared subclasses, right? So again, I have mentioned this. I'm not going to necessarily ask you about this, right? So I want you to know it exists, but don't worry about it because, again, I would not expect you to encounter this, or if you do, there's going to be a really small segment of what you are going to deal with. So you need to know it exists. I want you to be able to say what it is, but other than that, just say no. You can even write an exam. No, I'm not answering this. You told me to ignore this. Okay? I'll put it on and see how many of you actually do that, maybe. What a good idea. All right. So specialization, we start with the entity type, define the subclasses of the entity, right? So again, you're specializing things, right? So it's called top-down refinement, right? So you think about this, you've done top-down refinement in your programs probably, you've done it with your classes, you've done it with entities here, we do it all the time. And what's the opposite of top-down? Bottom up. So there's people that don't think top down. They think bottom up. I want to know all the details. Let me build it up. And then I go back in and eliminate things from the bottom up because I don't need them. Right? So all the books tend to talk about top down. I have a whole set of people that, matter of fact, I have even grouped my team that way. I put all the top down thinkers in one section, the bottom up in another one, and they are just all happy. Because when I had them mixed, when I first got there, like all the people that were like whoever's at the top as a team lead said this is the way we're doing it, and the people that didn't think that way had trouble getting there. Right? So it's just thinking about how people think, or don't think, as the case may be. Right? All right, so again, we have the top-down or bottom-up approach that we're gonna do, right? So again, some combination, but here's the bottom line on it. Right? Whether you do top-down, bottom-up, or you are doing some kind of combination, you are most likely going to end up with the same exact result of it working. It may not look exactly the same, but that's okay. We just talked about how the fact that you draw ERDs, the way that you think about it, the way you process it can be a little bit different. It's not going to be drastically different, but it's going to be very similar to what everybody else has, right? And other people that pick it up are going to know what you mean in general. Right? So we typically do some combination of these. Like I said, I have separated the groups out, and they get along really well, and we get done things faster because everybody's thinking the same way in their approach. Okay. All right, so here's a kind of another example that they tossed in there about the idea of, in this case, it's a university, so we have the magic person. We love it when you have a person, right? And it could be an employee, an alumnus, or a current student, right? And right, the employee or the student could be considered a student assistant, right? And so again, what do the D's represent? Disjoint, right? So that means that they can be in one or none of them, right? Okay, so what is the double lines? Total, right? So, right, you have to be part of that, right? Okay, when you come down from that. Okay, and what does the double oval around degrees mean? Multi-valued, so you could have multiple degrees like you are all agreed to have when you get done with this stuff. Okay. All right, so again, if we look at student assistant, in our scenario here, we have two paths up to the top. So multiple inheritance associated with that. All right, so we have a category of things called union types. So all the subclasses or superclass, subclasses, relationships we've seen have a single superclass. Shared subclass is a subclass in which we have the one distinct superclass or subclass. Each relationship has a single superclass. Shared subclasses lead to multiple inheritance, right? But sometimes we need to model a single superclass, subclass relationship with more than one superclass itself, right? So superclasses represent different entities. So the idea is that sometimes, if you just want to think about it in general, what union means, right? You guys all remember set theory and all that kind of stuff. So union means you're bringing it all together. That's all we're really talking about here. So they go through all these words to tell you that, right? So in the database for the vehicle registration, a vehicle owner can be a person, a bank, right, or a company, right? So we can have a category or a union type called owner that we create to represent the union of those three together, right? So what was our example that we just saw before? We also had a person at the university level, right? And why was that? What's the real kind of reason for doing that? They just want to have one starting point at the top. That's all they're really trying to do. Right? So instead of having employee, alumnus, and student all kind of separated out, they're saying, well, all of these represent one thing called a person, so I have this nice hierarchy that I can draw out. So what's the problem with that? Think about the ERDs that you drew for me today. Did you have any hierarchy?
No.
No. Right? Because we didn't break all of this down. Right? But if I'm having a hierarchy, because we have all these different subcategories and stuff like that, I want one starting point. And what is that one starting point going to be? That's what you are trying to determine with this union process. Okay? So, the issue that we have with this is a lot of times we will actually, when we go from this logical to a physical, we actually don't create a person, entity. We take the data that's on person and we put it on employee, and we take the data that's on person and we put it on alumnus, and we put the data from person and we put it on student, and we just let them be separate. So the issue that I'm trying to point out to you is that in all the textbooks and in the academic world, they all kind of put this union thing in here, but we don't do it in real life when we translate it. So what do you want your ERDs to represent? The things, the specific things you are dealing with, right? And even though it's true that we are dealing with a person, in this case, right? I would bet if you went around the university and talked to everyone, right? There would be not a single person that you interviewed that would talk about person. They will talk about employees, they will talk about students, they will talk about alumni, but they will not talk in general terms about, well, we have a person at the university. Right? What you want the diagrams to represent is if you pick this up and you give it to any person at the university, they're going to look at it and they're going to understand what you are trying to tell them. They should know, in general, what every one of the entities are. Right? So if you look at the university here, right? All of you know what a student is. You are one of them. I'm sure you know what faculty are. You know what employees of the university are. You know what courses are. You know what textbooks are. You know what buildings. You know what departments, right? We can go through a whole list of all those. And even though you are not directly doing all the stuff at the university, I would be able to pick the ERD of the university and show it to you, and you would be able to pick out and understand probably a good 90% of it without knowing anything else than you know today. Because you've been exposed to it. But if I come to you and say, well, we have a person at the university, you're going to go, well, what does that mean? That's going to be your first question. What does that mean? Well, it's the generic thing. It's the union of employee, alumni, and student. What? Why don't you just call them, right? So my point of going through all that is that, yes, we do have these. We talk about these in textbooks. Absolutely. And I get what they're trying to do, but my argument is the ERDs are representing the data that you have. It's representing the terminology. Remember we talked about the language that you have at the university, at your job, at your organization, talking about the system. Doesn't matter what it is, right? That's the terminology you want in here. And if person isn't part of that, I don't think it should be there. Right? Folks will argue at that point, but that's my view. So, as I can state it. Right. All right, so we have the differences, right? So you have the intersection and all that kind of stuff. So you have union and intersections just like you guys are used to in the past. All right. All right. So we have two categories, the owner and the registration vehicle, right? So the bank, the person, and the company ultimately end up being the owner. So we have the U representing union, right? Okay. Now, does this make sense? I would say this picture makes sense rather than the one that we talked about, a person, because you understand that there is a person that is ultimately going to own a vehicle. And we know that a bank can own a vehicle. And we know that the company owns vehicles. So when I talk about who owns vehicles, right, people are going to say, people own them, or a person owns them, right? Right? So this one, it fits because we didn't have one thing at the top, we have all the ones at the top, and we unioned them together to represent the owner before we go into the relationship. Right? Now, what this also implies is what? What do you see that is off of owner? What's coming off the owner rectangle? The relationship, but we don't have any attributes. What is that telling you?
It's all of the attributes of the entities, all of the subclasses.
Kind of, right? Because we don't have a owner, actual owner entry. This is a logical owner, right? The person exists in the person entity. The bank is in the bank entity. The company is in the company entity. Yes, we call them owners, and that's what this is telling us, but owner doesn't exist as a unique set of data. If I want to get the owner, I have to go to one of those three to get the actual data. But from a logical perspective, I want to know that going forward, when I hear owner in the terminology when somebody's talking to me, I know what that means. I know that that's person, bank, or company. Is that okay?
One question on that, previous slide. So the bank is denoted by a double line which is complete. So if the person does not have a loan, then it says a union, and the bank has a double line there.
So what is that? What's the double line mean? Total. So what this is saying is that every bank, right? So every entry that's in the bank entity is going to be an owner of some vehicle. Right. So in other words, I can have persons that don't own vehicles. I can have companies that don't own vehicles. But if I have a bank entity, bank instance, that bank has to be the owner of some vehicle. That's what that's saying.
Okay, so it's,
Right? So does that clear that up? Okay. So, again, the single line says partial.
okay.
So, a person may or may not be an owner. A company may or may not be an owner. But every bank instance has to be an owner of at least one vehicle.
So, okay, what are we really talking about here? Is it a vehicle system? Is it-
Yeah, right, so, right, who is the vehicle, whether it's a car or a truck,
Okay,
registered to,
okay.
right? So I have,
So
right,
we
so
need
if
to-
you look down at the bottom, we have car and truck, and we have a union upward.
Okay, so you need to read bottom.
Well, you can read it up or down, it doesn't matter, right? So if I read it from the bottom, it says, right,
Yeah, the
for
car.
cars or trucks, they, either of them can be a registered vehicle. And if I talk about a registered vehicle, I'm talking about a car or a truck.
Right.
Right? And who owns that registered vehicle? The owner owns it. And the owner can be a person, a bank, or a company. Reading down, a person, a bank, or a company can be the owner of a registered vehicle that can be a car or a truck. So you should be able to read it going up and going down.
So when you read from top down, without that context of the vehicle, this all becomes,
Okay, so let's take out all the union stuff, right? The owner owns a registered vehicle, right? That makes sense,
Yep.
right? So I have an owner who's going to own a vehicle that's got to be registered. And then I come back to you and say, okay, so who can an owner be? And you come back and say, it could be a person, it could be a company, or it could be a bank. Right? So then I add the top on. And then you say, well, what type of vehicle can the registered vehicle be? And you say, oh, it can be a car or a truck. So now I add the bottom. So again, you are relying on somebody walking you through what it means. And the typical scenario is they describe to you that the centerpiece.
Yeah.
And then you go, like I said, you asked the question, you asked questions earlier about as you were thinking about the scenarios, right? You go, well, what are the characteristics of an owner? Oh, well, there's different characteristics because there's different types of owners. You go, well, what different types of owners do you have? And you say, a person. Well, what data do you have about the person? Oh, I have a social security number, I got their name, I got their driver's license number, above, right? And you go, well, what other kind of owners do you have? Well, I got a bank. Well, what are the characteristics about a bank? Well, they are completely different than a person, right? So you have to remember, you're building this up. This isn't, right? Either you are very lucky and somebody has already got this built for you and they just hand it to you and then you can read through it and figure it out. Or if you are building this, you have to ask a whole bunch of questions to figure it all out because people are just describing things to you. And you're trying to figure out is there a category? Right? So you could say, right, I've got a registered vehicle of a car or a truck. Okay? And then a month later, somebody talks about, well, we register boats too. And you go, well, who owns a boat? Well, the boat can be owned by a person, it could be a bank, it could be the company, right? So you know to add this here. Right? Or you register a plane, since we're talking about airports earlier, right? No, but my point is that, right? A lot of times we go back and as we change the business, we get different products that we're dealing with, we're trying to deal with different data, we get different data from different places. We go back and change these. We don't change them often, especially the complete one. We don't change it very often, but we do change it because things do change. Right? And it's typically based off of someone describing something to you that you then interpret. Right? So again, the scenario is, well, we deal with planes. And you look on your things and everything says aircraft. Well, you need to know from the data dictionary, they go, planes are identified as aircraft in our documentation. Right? So something like that. Okay, does that make sense?
Yeah.
Okay. Okay, so some formal definitions, right? So, okay, I'm not going to ask you to memorize any formal definitions for any of this stuff, right? So don't go like crazy trying to think about this, right? So we have the idea of, we have classes, right? So a type of entity, right? And it could be subclass, superclass, categories, right? We have entities were replaced with classes, right? So this gets down way too much into the detail, right? Because this is all about programming. What are we at? We're at this logical level, right? So what I don't like about any of these textbooks is they drive you directly to definition of classes. How are you going to technically do it before you get your act together on the logical? And what happens if you dive into the details too quick? Yeah, if you didn't hear that, it was right. The big mushroom cloud appears, right? Because you have to make changes, and changes are a hassle, right? Okay, so right, it's great that the book talks about these formal definitions in terms of classes that you have dealt with in your programming classes, right? Okay, so we have all this inheritance and stuff, and we can talk about generalized and the totality and stuff, and all these wonderful little formulas and stuff, right? I don't care about the formulas. What I care about is that you understand what disjoint means. You can be in one or more, but you might not be in any, right? So disjoint, pick one or none. Overlapping, you can be in multiple. You can be in one. You might not be in any. Okay? And then what do we have if we have the double line? It is totality, right? So I want you to understand those concepts and be able to explain them. I'm not going to ask you to draw or come up with any of these kind of categories of things, right? Because you can always go back and look at these things, right? What I want you to get out of this is when you walk out of here, by the end of the midterm, you should be able to, I should be able to give you any scenario, and you should be able to draw me an ERD, and it's going to be perfect. That's what I'm looking for. Okay, so we have intersections, unions, and all that kind of stuff that we have in here. Right? They talk about the subclasses, and again, they fall into this kind of attribute defined scenario, so they give a formal definition for that. That's really nice. So read through this when you have, like, want to go to sleep or something, right? Something like it, right? So we have those kinds of things. Right? All right, so the final thing that we want to talk about real quick is, again, something I don't want you to ever think about doing at this point, right? And that's all of the UML diagrams, right? So they talk about, you use UML to draw your ERDs. No. The answer is straight out, no. Class diagrams in UML are for classes that you're going to create in a program. This is what? You are creating a document that you are going to show to people that you should be able to walk through, and whether they understand programming or not, they should be able to describe it to you. You should be able to take these diagrams, take it to your business customer, and they should explain it to you. Because it should represent their business. If they can't describe it, you got a business customer that needs some training. But that's what you do when you get a new one. Right? When I get a new business customer, which I just did about 3 months ago, the first thing I did was I tossed out the ERD in front of them and said, let me walk through this part of the business. This is everything data-wise that we deal with for you. And at the end it was like, I didn't know we did all that. Well, yeah, but we do. Right? So they gave you the nice little diagrams, they got all the arrows and stuff. This is too detailed. This is what you're going to build. You do this way in the design stage, right? Right? So again, stick at a high level. And speaking of a high level, that means it's time to leave. So have a great night. And where are you going to be next week? At home. Right? 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 If you want to come here and wait for us, feel free. Okay?